Chemistry lecture number 3, density calculations. In this lecture we're going to show you how to do density calculations where you have to solve for density, mass, and volume. And we're going to start easy and we'll get more complicated as we go along. Okay, let's try the first problem. What is the density of a rock that has a mass of 2.4 grams and a volume of 2 milliliters? Now anytime if you think you can solve this by yourself, hit the pause button and solve it and then hit play again and see if you got the right answer. But how do we go about solving this? Well, what I like to do is I like to write out what we have and what we ask for. They're asking for density, so I usually write D equals question mark. Has a mass of 2.4 grams, so they're telling you the mass, and grams is a measure of mass, so we can write M equals 2.4 grams, and they tell you the volume is 2 milliliters. Milliliters is a measure of volume, so V is 2.0 milliliters. And then we just write the formula, D equals M over V. D equals 2.4 grams divided by 2.0 milliliters, and then 2.4 divided by 2 is going to be 1.2, and then we have grams per milliliter. We can also write it 1.2 grams slash milliliters. Okay, that one's not too difficult. Let's try another one. What is the mass of 19.9 milliliters of coal that has a density of 1.5 grams per milliliter? And I'm going to sort of solve this two ways. In chemistry books, they tell you to include the units and to cancel out the units. And I'll do that once just to show that things work out. But frankly, I don't like doing it that way because I tend to get confused. All right, well, let's write what we have and what they ask for. They're asking for the mass. What is the mass? So M is unknown. And 19.9 milliliters. Milliliters is a measure of volume, so V equals 19.9 milliliters, and the density is given as 1.50 grams per milliliter. So grams per milliliter is the unit of density. Okay, so let's go ahead and put the formula down, and then we'll fill in the units. D equals M over V, and I'm going to include the units this time, which frankly I don't like to do. Grams per milliliter equals, and the mass, that's what we're solving for, and then the volume is 19.9 milliliters. Okay, so the way I'm going to solve this is I'm going to cross multiply, and I'm going to include the units. These units, I'm going to consider them as variables almost. Okay, so what do we have here? We're going to have ml times m. So I'm going to cross multiply these guys. ml times m equals these two things. 1.50 grams times 19.9 milliliters. All right. Now, we want our final answer to be in grams because they're asking for mass, and the unit of mass is grams. So I'm going to divide both sides by milliliters. And the milliliters cancel, and that's going to give us M, the mass, equals 1.50 times 19.9 grams. And all I did was I just moved the grams over. The order in which you do it doesn't matter. That's the transitive property, I believe, or multiplication. Anyway, M is going to be equal to 1.50 times 19.9. That's going to give me about 29.85 grams, and that's about equal to 29.9 grams. Okay, now that's the way you're supposed to do it, including the units and then canceling them out. Frankly, I've found that when I include the units, I tend to make mistakes and it confuses me. So If I can't do this correctly while including the units, then I don't expect you to do it either. Here's what I like to do. I just like to establish that I'm using the correct units, and once I use the correct units, I solve the problem without including the units, and then I just slap on the correct unit at the very end. So here's the shortcut of how I like to do it. So it's the same drill, you know, m equals question mark, v equals 19.9 milliliters, and then d equals 1.50 grams per milliliter. So my units are all correct. I'm just going to do d equals m over v. Density is 1.50, and I'm not including units this time. M is just going to be unknown. Volume is 19.9. All right, we're going to solve for m by cross multiplying. What I'll do is I'll just divide this number by 1. You divide a number by 1, you haven't changed it. 1 times m equals 1.50 times 19.9. 1 times m is m. 1.50 times 19.9 is going to give me about 29.85. And then rounding to correct figures, we'll talk about rounding later, that's going to give me about 29.9. And since this is mass, the unit of mass is grams. So that's how I like to do things, and that's how I'm going to do it from now on. And by the way, it's the commutative property of multiplication, where you can, it doesn't matter the order in which you multiply it, for all you math freaks out there. All right, let's try another problem. Ethanol has a density of 0.789 grams per milliliter. What is the volume of 3.95 grams of ethanol? Let's see. So they're telling us the density. D equals 0.789 grams per milliliter. And let's see. What is the volume? So they're asking for V of 3.95 grams. So mass equals 3.95 grams. Grams is a measure of mass. That's what m is equal to. Here we go. D equals m over v. And then density is 0.789. M is given as 3.95. And we're going to solve for v. Okay, well, just to make things easy on myself, I'm going to take this number and divide it by 1. Dividing by 1 doesn't change the number. Now that I've divided it by 1, I can cross multiply. 1 times 3.95 equals 0.789 times V. All right. So 0.395 times 1 is 3.95. And then what I'm going to do is I'm going to divide that by 0.789. So 0.789 V divided by 0.789. All right. That cancels. This number divided by this number gives me 5.006 equals V. And then we can just rewrite this as V equals about 5.01. And what's the unit for volume? It's milliliters. So that's your answer. Okay, now those are the simpler ones. Let's do one that's a little bit more complicated. A graduated cylinder has a mass of 5 grams. When 8 mils of liquid is added, the mass of the cylinder in liquid is 21 grams. What is the density of the liquid? Okay, well, here's what's going on. You have an empty graduated cylinder, and I'm going to move the camera a little bit so we can see this a little bit better. We have a graduated cylinder that's empty, and then what we're going to do is we're going to weigh it. So we'll take a scale, and we'll put the graduated cylinder on the scale and see how heavy it is when it's empty. So when it's empty, it has a certain mass, but if I were to add a liquid to it, Okay, so now I've got the graduated cylinder filled with a liquid. And if I were to put it on the scale, it would be heavier than it was compared to when it was empty. So, one way to figure out the mass of the liquid is just to compare the mass of the cylinder filled with liquid as opposed to being empty. Okay, let's see if I can get this readjusted. So, here we go. All right, so here's our graduated cylinder. Empty. The mass is 5.00 grams. All right, but then when I fill it with liquid, 8 milliliters worth, the mass now is 21 grams. All right, so to get the mass of the liquid, it's just going to be the mass when it's filled up, so it's heavier here, it's 21. And then here's the mass when it's lighter, it's 5. And so it's going to be 16 grams. That's the mass of the liquid. That's how heavy the liquid is. So now we can solve the problem. Let's see. The mass of the liquid is 16 grams. The volume is 8 mils. We're trying to find the density. Okay, here we go. D equals m over v. D equals 16 divided by 8. That's going to give me 2 grams per milliliter. All right, so that's how you solve that one. All right, let's try another one. A block has dimensions of 4 by 3 by 2. The block has a mass of 10. What is the density of the block? All right, so we've got a block. It's 4 by 3 by 2. Four by 3 by 2. So in this problem, they don't tell us the volume of the block, but we can figure it out. The volume of the block is length times width times height. So the volume of our block is going to be 4 centimeters times 3 centimeters times 2 centimeters. 4 times 3 times 2 is 24. Centimeters times centimeters times centimeters is centimeters cubed, which is the same thing as milliliters. So that's our volume. All right, so now we have our volume. So V equals 24 milliliters. Mass M is 10 grams, and we're trying to find the density. What is the density? Here we go. D equals M over V. D equals 10.00 divided by 24. Our density is going to be 0.41666, which is about 0.417. And the units of density? Grams per milliliter. So here's sort of a similar problem. A stack of coins. So if we have coins and we put them into a nice stack, we get a certain shape. A cylinder. So stack of coins makes a nice cylinder shape. And let's see, in this problem they tell us the diameter of the coin is 1.27, the height is 4, and the mass is 12. What's the density of the coins? Well, let's see. Notice again that they don't have the volume. We have to figure it out. Well, let's see if a stack of coins makes a cylinder. So here's my stack of coins. And they tell me the diameter is 1.27 centimeters. And then the height is going to be 4 centimeters. If this is the diameter, then the radius r is going to be 1.27 divided by 2. And that gives me a radius of 0.635 centimeters. All right, when we have enough information, we can find the volume of this stack. The volume of a cylinder, remember from geometry, pi r squared, which is the area of the top, times the height. Anytime you multiply the area of a regular figure by its height, you get the volume. Okay, so the volume of our figure is going to be pi 0.635 squared times the height. If you grind the numbers out, you're going to get 5.067 units, centimeters cubed, because all these length units, diameter and the height, are in centimeters, which is the same as milliliters. Okay, here we go. D equals m over v. Here's the mass. It's in grams, so that's going to be 12.00. The volume goes there, 5.067. Density of our stack of coins turns out to be 2.3682, which is about 2.37 units of density, grams per milliliter. Okay. One last problem. A gold-colored rock, like that, has a mass of 19.2 grams. When it's placed in a graduated cylinder filled with 6 mils of water, the volume increases to 10 mils. What is the density of the rock? And if the density of gold is 19.3 grams per milliliter, is the rock made of gold? All right, so this is a problem that shows that you can find the density of irregularly shaped objects by dumping it in water. It's hard to figure out the volume, how much space this takes up, because it doesn't have a regular shape. So here's another rock that doesn't quite have a regular shape, but I can find the volume of this rock if I took some water, and I'm going to move the camera again. Hold on. Alright, so if I have a graduated cylinder and I have a rock, the displacement of the fluid as I drop the rock in will tell you the volume of the rocks. Right now the volume is at about 21, but if I just drop this in, yoink! So see how the volume went from here to here? So the change in volume tells you the volume of the irregularly shaped object, in this case our rock. So, back. Okay, so picture of what's going on here. We've got a graduated cylinder filled with 6 mils of some liquid. We're going to throw a rock inside, and then what happens is the volume increases. So here's our rock from 6 mils to 10 mils. Okay, so 10 minus 6 will give me the volume of the rock. So the volume is just 10 minus 6. And the volume of our rock is 4.00 milliliters. The mass of our rock is right here, grams. So m equals 19.20. D is m over v. Mass is 19.20. Volume is 4.00. Our density then works out to be 4.80 grams per milliliter. And at that density, that tells us that our rock here is not real gold. In fact, The density of gold should be 19.3, and this density is a lot less. And in fact, 4.8 is about the density of fool's gold. So that's one way you can use density to tell the difference between real gold and fake gold. But it's not completely reliable. The density of tungsten is very close to the density of gold, and people of low moral value sometimes trick people into buying tungsten painted gold, and they say, oh, it has the same density of gold. So don't use chemistry for bad purposes. Just use it to verify whether something's real gold or fake gold. All right. Thanks for watching. Oh, and if you want to get a PDF file of this lecture, go to www.richardlouis.com. This is chemistry lecture number 3 on density. Thanks for watching.